Hello everyone. Before starting preparation for any competitive examination, you must have 100% idea about the syllabus. Now let us have a look at the Jam 2022 chemistry syllabus. Let's begin with what are the major topics that need to be focused. So in organic chemistry, basic concepts in organic chemistry, organic reaction mechanisms, that includes named reactions and reagents, natural products, heterocyclic compounds. And you have special topics like stereochemistry, pericyclic reactions, and spectroscopy. These are the major chapters in organic chemistry. Moving on to physical chemistry, you have chemical kinetics, electrochemistry, chemical thermodynamics, colligative properties, ionic and phase equilibria, and finally gaseous state and solid states. Moving on to the inorganic chemistry, you have periodic properties, chemical bonding, main group elements, means S block and P block elements. Then you also have coordination compounds. Now let us move on to the detailed analysis of various topics. The basic chapter in organic chemistry is the basic concepts in organic chemistry. To be precise, electronic effects. So we have some permanent effects like inductive effect, mesomeric effect, hyperconjugation, and some temporary effects like electromeric effect. In addition to these electronic effects, you also need to incorporate the steric factors. Like for all inductive, mesomeric, and hyperconjugation put together, you need to study their applications like acid strengths, like carboxylic acids, phenols, then basic strengths, various aliphatic and aromatic amines and substituted amines, etc. So for this, you also need to have an idea about the acid-base concept in terms of Lewis theory, in terms of Bronsted theory. Okay. Then you also have reactive intermediates that include carbanions, carbocations, free radicals, carbenes, nitrines, and benzene. So for all these reactive intermediates, you focus on their generation and their reactivity, stability, and also the various reactions that involve these reactive intermediates. You have reaction mechanisms that include addition reactions, substitution reactions, elimination reactions. Again, addition reactions could be electrophilic, nucleophilic, and free radical additions. You have substitution reactions in which you have aromatic substitution and also aliphatic. Aliphatic means SN1, SN2, and SN9 mechanisms. Aromatic, you have two mechanisms, addition elimination mechanism, also called as arraign, in which sigma complex is formed. Then you have elimination addition mechanism, which is also called benzene mechanism. In elimination, you focus more on E2 elimination and their stereochemistry. Most of the times, they will give some cyclic compounds in which you are supposed to focus on the stereochemistry. So which type of product is formed? Is it Hofmann product or Syllabus product? Then certain name reactions. So luckily, we have certain reactions. They're precisely mentioned. So if it is simply name reactions, the scope is very wide, but we have some limited reactions like Curtius, Lawson, Hofmann, Wolff, etc., Simmons-Smith, Favorsky, Benzelica, some rearrangements like Bayer-Williger, Pinnacle-on rearrangements, etc. Okay, so focus on those all named reactions. So if you combine these electronic effects and reaction mechanisms put together, you'll get at least 20 marks. If you're perfect in this, that includes even organometallic reagents like Grignard reagent, organocopper, organozinc reactions, and pericyclic reactions, oxidations and reductions, functional group interconversions. This is again a broad chapter. So start from alkanes, alkenes, alkynes, alkyl halides, alcohols, ethers, carbonyl compounds, then carboxylic acids and their derivatives, hydrocarbons, then diazonium salts, etc. you try to have the major reactions of each class of compounds, both preparations and properties, so that you can attempt a question on these things, which will also include some reagents. In pericyclic reactions, in majority of the cases, you will get a question on the Diels-Alder reaction, which is a classic example of a cycloaddition reaction, and also the electrocyclization reactions. Most of the times, they will not touch this, what you call as sigmatropic reactions, but you try to study both cycloadditions, electrocyclic, and also sigmatropic reactions. Then you have structural problems using some chemical reactions. Once you study all the families of reactions, you will be able to do the questions on these things. So you don't need to have a separate heading for these things. Once you study all these different classes of compounds, their interconversions, then oxidations and reductions, and certain reagents, certain named reactions, you will be able to attempt questions on this. Okay. In stereochemistry, you will have to focus on the criteria for optical activity. Sometimes you will have the chiral centers. You may also have optical activity of organic compounds that do not have a chiral center, particularly allenes, biphenyls, and spirines. You focus on those criteria, that is absence of what you call as certain symmetry elements like plane of symmetry and the center of symmetry. Then RS nomenclatures are also important. In conformational analysis, mostly questions could be asked on cyclic compounds, particularly disubstituted cyclohexanes and their stabilities. And in qualitative organic analysis, certain chemical tests which you will already do in various earlier chapters. Then you have spectroscopic techniques, like you also have in physical part, you also have microwave spectroscopy. Then in the organic part, you need to focus on UV visible, IR, HNMR, and also mass spectrometric techniques. Then how you use these techniques in structural elucidation. So you can expect at least 8 to 10 marks in this spectroscopic chapter. Then in natural products, most of the times question could be focused on their structural aspects, like isoprene rule, etc. in alkali. Sometimes in carbohydrates, they will ask you to structures of disaccharides, and then linkage, what is the type of linkage, etc. Sometimes in nucleic acids, they can ask the structures of bases, pyrimidine and purine bases, like that. Then aromaticity, so a compulsory question, which are aromatic, which are non-aromatic, which are anti-aromatic, using Haeckel's rule, Craig's rule. You also need to focus on the that is homoaromaticity, annihilation effect, etc. Then synthesis of various things, and also the reactivity is also more important. So both electrophilic and also nucleophilic substitution reactions in aromatic, particularly monocyclic, bicyclic, and tricyclic, like naphthalene and anthracene. In physical chemistry, major chapter, one of the major chapters is chemical kinetics, in which you need to focus on the various rate equations, both the differential and integrated forms. Then order, molecularity of a reaction, the temperature dependence with special focus on Arrhenius equation, where you can expect a problem. Then complex reactions like parallel reactions, opposing reactions, etc. You also have unimolecular theory by Lindemann, and also catalysis. Moving on to the electrochemistry, one part you can say there's conductometry, conductance you can say. That include Faraday's law, Skorla's law, their applications, strong electrolyte Debye theory. Then you have EMF, their measurement and their applications, the EMF series, etc. This is again one of the major chapters in physical chemistry. And then you have thermodynamics. So various laws, first law, second law, third law, reversible and irreversible process, isothermal process, adiabatic processes. Then the various equations using calculation of entropies, calculation of internal energy, free energy, etc. So that is thermodynamics. Also, you have thermochemistry. Then you have Gibbs-Duhem equation. chemical potentials and their applications. This is again very important because even these concepts we will use in different places, like ionic equilibria, we will also use in organic chemistry, we will also use in physical chemistry also. The ionic equilibria, various equilibrium constants, Rayleigh-Chatelet principle, pH, buffer solutions, salt hydrolysis, solubility and solubility products. It's a very important aspect of the ionic equilibrium. Then acid-base titrations, dilute solutions, particularly with a special focus on colligative properties like relative lowering of vapor pressure, depression in freezing point, elevation in boiling point, osmotic pressure. Then abnormal molecular weights. So this is very important. Most of the times question could be asked on very fundamentals only. Then you have phase equilibria with single and two component phase diagrams. Moving on to the gaseous state, kinetic molecular theory. Then you also have Maxwell-Boltzmann distribution of molecular velocities. Then deviation of ideal gases from deviation from ideal behavior. Then you have, that is the concept of real gases. Then van der Waals equation, various terminology, various constants involved. Then you have critical state, critical constants, law of corresponding states. And finally, solid state, you have unit cells. We have Bragg's law, then certain crystal systems like NaCl, cesium chloride, etc. These are covalent crystals, these are ionic crystals. Then you have defects in crystals, like stoichiometric defects and also non-stoichiometric defects. You also focus on the semiconductors, insulators, etc. This is a simple chapter, mostly theoretical aspects will be asked in this. Types of adsorption, colloids, emulsions, etc. Then you also have deadsorption isothermal, like Freundlich, and you have one more. Then you have spectroscopy, already we have discussed. That is a physical part of this spectroscopy. Most of the times, the question could be on Beers-Lambert's law, and also the what you call as rotational spectroscopy. You can expect a theoretical question. Moving on to the inorganic chemistry. This is basic and fundamental chapter in inorganic chemistry. One is periodic properties. Mostly question could be asked on periodic properties, but you need to have a complete idea about the total periodic table. So which element is present, that is in which group and which period, that is position of the element, its electronic configuration, and their gradation in various periodic properties, like radii that include atomic, covalent, ionic radii, then ionization enthalpy, electron gain enthalpy, electron negativity, and electronic configurations of certain molecules. Then in chemical bonding, this is also one of the important and major chapters and also fundamental chapter. Focus on the ionic bond with special focus on Born-Haber cycle and also salvation energies. Then moving on to the covalent bond, Vesper theory, that is particularly shapes of various molecules. Then Fazan's rules, then valence bond theory, MOEDs, molecular orbital energy diagrams of certain diatomic, homoatomic, and heterodiatomic molecules. The radicals positively charged species, negatively charged species, then dipole-dipole interactions, hydrogen bonding, their applications, etc. Moving on to the main group elements, you need to focus on particularly the metals in liquid ammonia, minute pair effect, then the structures, synthesis, and the properties of certain compounds of particularly carbon, nitrogen, phosphorus, and sulfur, with special focus to silanes, silicones, boranes, boragine, then phosphogene, etc. Then also you have xenon difluorides, and finally oxides of nitrogen, phosphorus, sulfur, and also oxo acids of phosphorus, sulfur, and chlorine. You also have halides of silicon and phosphorus. Particularly, most of the times question could be asked their reactions and structure and synthesis. Transition metals looks to be simple, but this is one of the biggest chapters in inorganic chemistry. Characteristics of D block elements, oxides, hydroxides, then comparison between first row, second row, third row, and coordination complexes. So various theories related to structure. Then you have isomerism, reaction mechanism, and electronic spectrum. So we have valence bond theory, molecular orbital theory, CFT. Okay. Then focus on the magnetic and color properties of the complexes. In reaction mechanisms, study the reaction mechanisms involving octahedral complexes and square planar complexes. In square planar complexes, with a special focus on the trans effect in organometallic compounds that include metal carbonyls, most of the time structures, metal nitrosyls, metallocene structures, and also 18 electron rule is also very important. Most of the times question could be asked on that. Then homogeneous catalysis includes Wilkinson catalyst. Bioinorganic chemistry, various metal ions and their applications in biological systems, also structures and functions of certain biological molecules, important molecules like myoglobin, hemoglobin, and carbonic anhydrase. Metallurgy is also there, focus on the purification, isolation, and also principles and application of Ellingham diagrams. You can expect a question on here. And remember, most of the times you will have the certain questions will be purely based on theoretical concepts, straight away direct questions. But about 60% of questions will be applied type. In physical chemistry, you need to solve problems. Even in organic chemistry, you need to apply the concepts to solve and arrive at the conclusion. Like 3-4 steps, they will give 3-4 steps. Reactant, then product, in between 2 to 3 steps. What are the reagents used, or what are the reaction things that are conditions used in those 3 or 4 steps sometimes. A to B, B to C, C to D type of questions actually. So in total, you have 22 chapters. But remember, if you can look at all these things, you can put them on your fingers. Coming to organic chemistry, structural theory, reaction mechanisms, including named reactions. Then you have pericyclic reactions and spectroscopy. And physical chemistry, you have electrochemistry, chemical kinetics, thermodynamics, solutions that including colligative properties and also solid state, major chapters. In inorganic chemistry, periodic table, chemical bonding. Then you have transition elements that include coordination compounds and also main group or main block elements. You also have certain small topics like adsorption, that is surface chemistry, and bioinorganic chemistry, etc. So these are the major chapters. It looks big, but once you go on exploring, so try to focus on these major chapters first. If you find the time, you go for other topics like smaller topics which are less important. And don't go by whatever the topics you are going to study, you put maximum effort in the initial stage. If they are very difficult, so leave them for the later stage. If you start with the comfortable topics, then slowly increase the complexity. So don't read anything that is not required. Don't leave anything that is required. That is not a word less, not a word more. This should be your preparation strategy. So start working, work till the eyes are heavy and dim. Nothing else, only jam. Then work till the mind begins to swim. This should be the preparation strategy. So remember, if you believe in yourself, you are going to make it. So there is a saying, whatever the mind of man can conceive and believe, it can achieve. So remember that one. So believe in yourself. Okay. Wish you all the best. Thank you very much. So if you look at, it's not difficult, because if you get 25 to 30 marks, you will land up in some IIT. If you get 15 to 20 marks, you will get a seat in NIT. If you have reservation category, you can have you can get even lesser marks, even 12 marks. If you get 12 marks in reservation category, you will get a seat in some or the other NIT. So once again, wish you all the best. Focus. So make use of these 30 days. Make a perfect preparation strategy. No parties, no enjoyment. Okay, you can give your own proper parties later. Okay, so don't waste your time. Wish you all the best once again. Thank you very much.